Hello everyone, welcome to my YouTube channel. Today I am here with a new video of mathematics chapter sets of class 11th. In this video we are going to clear all our basic concepts that are necessary for this chapter. So without wasting time, let's get started. On starting, the first thing that arises in our mind is what actually a set is. Set is basically a well-defined collection of data. For example, set of books. It can be a set of any other thing. The next thing is how to represent the data. So, representation of data include two forms. The first one is roster form and the another one is set builder form. Roster form is a form in which we list the numbers of the set within braces separated by commas. For example, let's take set A that is having three elements that are 1, 2 and 3. These three are closed within the braces and are separated by commas. So this is the one way in which we can represent any data, and it is also a form in which we can represent any set. The another thing that we are having is set builder form. In this form we write a variable. Let's take any variable x or any other variable of English alphabet representing any member of set followed by a property satisfied by each member of a set. Let's take the same set A. Here the property that we can easily classify is every element is a natural number and all the elements that are here are up to 3. That means the natural number less than 4. So we have written x is any natural number less than 4. So this is the another way of representing any data. The next topic we are having is types of set. So there are different types of set. We are going to discuss them one by one with their examples. The first type of set that we are having is null set, also called void set or empty set. So any set that is not having any element in it is called null set, void set or empty set. It is represented by 5. Its symbol is like this, or just open braces that are not having any element in it. Let's suppose in set builder form we can say that x is a natural number that is less than 2. The next type of set that we are having is singleton set, as its name represents single. That means having only one element. Certain examples are given below. For example, any set A is having element 5, so there is only one element present in it. The next one, B set, is having only one element 0, so 0 is also counted as element, and if any of the set that is having 0 in it as its element, then also it is a singleton set as it is not having any other element in it. After discussing about singleton set, the next type of set that we are having is equal sets. As its name represents, equals means that are actually equal to one another, and the sets whose elements are same. For example, let's take set A that is having elements 2, 5, 6 and 9. The next set B that we are having on our slide contains element 9 that is also present here, 5 that is also present in set A. The next one is element 2 that is also present in set A. The next one is element 6 that is also present in set A, as all the elements are same. Now let's take one another example. If we are having set A that contains element 1, 2, and the next set B that contains element 1, 2 and 3. Here we can see 1 and 2 are the elements that are present in both sets A and B, but now 3 is the element that is not present in set A, hence we cannot say that both the sets are equal to one another. So let's go to another type of set. The next one is finite and infinite sets. Finite sets, as its name represents, finite means that is simply countable and that can easily be represented as set, like set of natural number, set of integers, set of rational numbers, set of months or anything else. If we are talking about infinite sets are the sets whose elements cannot be easily classified as simple data. For example, if we are talking about set of 10 best cricketers, it varies from person to person, so it is not actually a set of most talented writers, so it is a thing that vary from person to person, so it is not be classified as a set. We have talked about equal sets. Now it's the term to discuss about equivalent set. You can easily see the parrots that are present here. Something is similar in them, but the one thing you can recognize that is different in them is their color. Simply equivalent sets are the sets that are having same cardinal number. So what is actually cardinal number? Cardinal number is just the number of elements that are present in a set. For example, if set A contains element 1, 2, 3, here the number of elements that are present is 3, and the set B that is having also 3 elements, that is 4, 5, 6, here the number of elements is 3. Here the cardinal number is same, so we can say that these two sets are equivalent set. Now one thing we need to remember is all equivalent sets are not equal set, but all equal sets are equivalent sets. Now we are going to discuss about a new topic, subset. So what actually a subset is? Let's take one example and then we will be discussing about it. Let's suppose a set A is a subset of B. So what is subset? If every element of A is also an element of set B. Here the example is given. Set A is having 3 elements 1, 3 and 5, and set B is having elements 1, 2, 3, 4, 5. Here we can easily see that 1 is common in them, 3 is common in them, and B is 5 is common in them. So we can simply say that A is a subset of B, and we cannot say that B is a subset of A. We need to remember one more thing, that phi is a subset of every set. The next topic is power set. Oh my god, what is power set? Power set, if set of all subsets of set A is called a power set of A. So what is actually power set? It is denoted or represented by P A. Here P refers to power and we read it as power set of A. So now we are taking one example. Let's take set A is equal to 1, 7. Power set of the set A is 5, 1, 7, 1, 7. Here we are representing all the elements on it. One formula of finding the power set of any set that is given to us is 2 raised to the power n. Let's take the example. Here the set A contains 2 elements. Here n refers to the number of elements that are present in any of the sets. So if we are finding the power set of it, so 2 raised to the power 2 is equal to 4. That's what we are getting here as power.